Welcome to the StraightUp Solar webinar on Helioscope. My name is Kai. Use Helioscope to lay out a solar array for your home. Here I've picked a home in Bloomington, Illinois that has a nice south-facing roof. I'm going to walk you through how I go about laying out modules on a home like this. To give you some background, I would already have the electricity use for this home, so I know how many modules I need to put up there to get them to 100% offset. But for this example, I'm just going to maximize the solar potential of this roof. One of the first things I do is scroll in to take a look and see if there are any protrusions like vent pipes or anything like that coming off of this roof. And you can see here it's a nice clean surface, albeit a bit jagged, but that's fine. You'll see that the software can handle that very easily. Here is the roof ridge, and we can see a couple of protrusions here, but that's on the north side of the roof, where I will not be putting any modules, so we don't have to worry about that. Now, one of the first things that I do when I am creating a design, even though I want to jump right in and start putting modules on the roof to see how many I can get, I back out of this and I go into this field here called conditions. What I'm doing here is I'm selecting weather data that will show us over a long period of time, in some cases up to 20 to 50 years, what the history of this particular location has been and how much production we can expect from the system given weather patterns in that area. So you can see that the software has defaulted to the nearest condition set, which is the Central Illinois Regional Airport. I'm going to go in there and edit it very quickly. Yes, indeed, it is Central Illinois, but it's named it Condition Set 1. I like to have a very specific name for it, so I usually copy the name of the condition set and put it in there. There's a lot of detail as to what these numbers mean, but just for your general knowledge, the higher the number after TMY, the better. And then the lower the Roman numeral, the better in terms of the quality of the data. I'm not going to go into the detail of that. Just take my word for that, okay? So I've updated the condition set number 1. I'm going to add 2 more. The reason for this is, first of all, here we are, the pin is where this project is. And I'm looking for weather data that's on the same latitude as the subject property. Zoom in a bit here. You can see that there is only one, that's the one in Bloomington. All the others are either north or south. So I'm going to try to find the ones that are closest to this subject property. So the University of Illinois, the University of Illinois, that can't be Wisconsin. Anyway, the Bonneville location, I'm going to copy that and make that my condition set number 2. I'm going to create a third one. The third closest, which in this case is Decatur. Ooh, that's straight south. I don't know if I want that. Let me see, Peoria. So I'm going to pick Peoria over Decatur. You notice Decatur is 40 miles away, but it's due south. So the data there is not going to be really indicative of what's going on in Bloomington. So I'm going down one more to Peoria, which is west. And I will pick that as my third data set. The reason I have 3, it's because once I've created my design and I run a report, you're going to see 3 different production factors. And I throw away the lowest and the highest and pick the one in the middle so I can be reasonably conservatively sure that the layout I have created is going to produce the amount of power that I estimate. You'll see that in just a second. So I'm done with my conditions. Here I go back to my design. Again, I'm really, really excited to be creating this design. I want to go ahead and lay out modules. But before I do that, I know that in the city of Bloomington, it is required that you stay 3 feet away from the ridge and also 3 feet away from the eaves. There's no restriction on the front end, although for StraightUp Solar, we do have a 1 foot setback so that our installers have room to work. But the city of Bloomington requires 3 feet back from the ridge and 3 feet back from each edge. eave. So I'm going to go ahead and click on Keep Outs, and I'm going to draw a keep out along this ridge right here. Double click on it, it creates it. Now notice over here, the setback is at 0. I'm going to make that 3 feet. And I don't know if you can see, there's this sort of faint orange glow. And in that glowy orangey area, when I lay out my modules, it will not allow any modules to go into that area. I'm going to do the same thing on this eastern eave right here. Again, you see the orange area. I'm going to do it here. And then you notice it bumps out a little bit, so I'm going to do it here as well. So now I have created keep outs, and no modules will be allowed to fit into the shaded orange areas. Now I'm ready to do the thing I was excited to do in the beginning, which is to lay out the modules. So I create a new field segment. I want it to start up here, all the way to the edge of the ridge, down this eave, along the bottom, up a little bit, along this gutter edge, up, along this gutter edge, up this ridge, and I'm going to double click here, and I'm done. And voila! Like magic, here are the modules. Now, I'm a bit of a perfectionist, and I like things to look nice. So I'm going to set the top edge of this array as up here. See, it squirted it along a little bit. So now we have REC 320 watt modules, which are really nice black on black modules. And since this is on the front of the house, this is why I've chosen these 320s for aesthetics. I could select 325 modules if I wanted to. They have a little more power. They're a little more, the cost is not quite as high. So I know that this is a single story home. So I'm going to put the height here as 12 feet, which is the height up to the gutter edge. The azimuth here is 178 degrees, which is very close to 180. So I know that my modules are facing due south. They are in portrait mode. And if you see here, it's got a 1 foot setback. So if I zoom in a little bit, you'll see along this bottom edge, here we have the light orange keep out area. So I know that the modules are 1 foot away from the edge. So our installers will have lots of room to work. If we look here, you'll see that there are 54 modules in this design, producing 17.3 kilowatts DC of power. So this is a nicely sized system. Given the renewable energy credit limitations, I would probably resize this, but that's a conversation for another day, perhaps. And in terms of laying out modules, this is the process for laying them out. I can also look at this in a 3D view, which shows me what the modules look like on the home, given that 12-foot height to the gutter edge and what the roof looks like at a 24-degree tilt. If the roof was, say, more like 28 degrees, I could adjust that here, and it would adjust the layout accordingly. So here is my initial solar layout. I have my 54 modules, 17.3 kilowatts of power. The next step is to pair this with an inverter. The modules are producing DC power, and we use AC power in our homes. So typically we will use an inverter that will convert that DC power into AC so it could be used in the home. If I click over here onto my electrical tab, since there are no obstructions to the south of this home, I don't expect there to be much shading. So that guides my choice of inverter to the SMA line of string inverters. Now I've got 17.3 kW. The largest SMA I can use in a residential setting is 17. The software automatically puts 2 of them there for a ratio of 1.13. Again, that's a discussion for another day on the DC to AC ratios, but I'm going to just let you know that that's a good ratio. I know that the electrical panel for this home is over here to the west side of the building, so I'll move the inverters there. I will add a DC pin, which I will move over here to indicate where the connection is going to be made. And this is the interconnection button. I'll move that over here. So now we have the array up here. Our installers are awesome. They will run the conduit in your attic. It'll pop out of the soffit right here, and it'll run straight down to your meter. Nice, clean install. So I have a 54 panel array. I've got two Sunny Boy 7.7 kilowatt inverters, creating a 15.4 kilowatt AC system. Now I can go and look at how much power this produces. I'll save and exit from here. I'll go to my reports, and here are my 3 condition sets, and I'm going to simulate the energy being produced by that array over a year. In Central Illinois, it's telling me it's a 1,268 production factor. This is kilowatt hours per kilowatt of power on the roof. Peoria says 1,387.5, and University of Illinois says 1,258. 1,258 is the low, 1,387 is the high. I'm going to pick this number from Central Illinois, 1,268. And if I click on here, it tells me it's going to produce 21.9 megawatts of power. So I would compare this to how much energy the customer was using. If this was too much power, I could go back into my design and take some modules out. If it's not enough, then I can look at using a more high-powered module to get them more energy. So that's the basics of Helioscope design. I hope you found this interesting. We have ways for you to ask questions. Please do so, and we'll be happy to answer them. Thank you much, and until next time, this is Kai signing off.